Good morning, class. We are looking at Chapter 10, Analytic Geometry, Section 10.2, the hyperbola. We've covered the circle previously, and in this module, we covered the ellipse, now the hyperbolas, and the objectives are determine general and standard form of equation of hyperbola, graph hyperbola with centers at the origin. So let's refresh everyone's memory. The distance formula is the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared when a pair is given. The midpoint is x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2. When you have a double cone, the way you cut that, it creates the shape of interest. So if you cut it with a plane perpendicular to the axis, gives you circle. If it's tilted, it gives you an ellipse. If it crosses one side, it gives you a parabola. And if it's parallel to the axis of symmetry, it creates a hyperbola. So what is a circle? Has a specific definition. A circle is the set of points in a plane that are the same distance called the radius from a fixed point called the center. As a result, we have the following formulas. Centered at 0, 0, the origin, x squared plus y squared equals r squared. Centered at h and k, x minus h quantity squared plus y minus k quantity squared equals r squared. Definition of an ellipse. An ellipse is a set of points in a plane. The sum of its distances from two fixed points is a constant. The length of the major axis, 2a or 2b, depending upon whether it's elongated along the x or the y-axis, along the x2a, along the y2b. The two fixed points are called the foci. Each is a focus of the ellipse. F1 and F2 represent the two foci of an ellipse. So in short, we have the following formulas. X squared over a squared plus y squared over b squared equals 1. If it's centered at 0, 0. If it has a different center, such as h and k, x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. And when it's elongated along the x-axis, this is point A and it's larger than b. Then when a is larger than b, c squared equals a squared minus b squared. And if b is larger than a, c squared is b squared minus a squared. The area of a circle is pi r squared. For an ellipse becomes pi ab because if a and b are the same, becomes a circle, and we call it r. So circle is a special case of an ellipse. So any point on the ellipse with coordinates x and y connected to the two foci, the distance from P to F1 and the distance from P to F2, they add up to 2a. And of course, this is to everybody. So PF1 and PF2. In this case, the vertices are along the y-axis, and this is larger. Now, as far as I'm concerned, I always keep them as follows. I call this A, okay? And this one is P. So that's the way I like to keep them. So if you do it that way, the formula remains the same, and I'm going to do the same thing with respect to hyperbolas. All right. Then point to the hyperbolas, and these are various shapes. A hyperbola is the set of points in a plane, the difference of whose distances from two fixed points called the foci is a constant. Remember, in the case of ellipse, is the sum. Now it's the difference. For every point on the hyperbola, the difference m minus n is the same constant. In other words, pick a point connected to the two foci, focus 1, 2, m minus n. If you put it here, m minus n. If you put it here, this is longer, so this becomes m minus. So for example, if I pick this point and connect it to this one, then obviously this is the largest one. Okay, this one. Their difference remains constant, which is 2 times a. So, or for example here, this is d of f1p, the distance between these 2 points, and this one is the d of f2p. This axis is called the transverse axis. These 2 points where the graph crosses the x or the y-intercept is called the vertices, because if it opens sideways, we have x-intercepts. If it opens up and down, we have the y-intercepts. So a hyperbola has 2 vertices. The vertices are the points where the graph crosses the x or y axis. Center. The point halfway between 2 vertices is the center of the hyperbola. Transverse axis. The line through the vertices is called transverse axis, the line that connects the two. So it's pretty straightforward. Those are all types of definitions. And as I mentioned, if it opens sideways or if it opens up and down. When it opens up and down, the vertices are along the y-axis, and so is the transfer axis. Transverse axis would be the y-axis in this case. And if it's not along the x or y-axis, still when you connect the 2 vertices, that line would be the transverse axis. Graph hyperbola center at the origin. The formula is x squared over a squared minus y squared over b squared equals 1. This is when the graph crosses the x-axis. Hyperbola centered at the origin. Vertices are minus a0 and a0. Transverse axis along the x-axis. Asymptotes. Y is plus minus b over a times x. So b over a times x and minus b over a times x. Now, I'm going to keep the b squared under y squared, and y squared over b squared minus x squared over a squared equals 1. When I do that, the asymptotes remain the same. These are the hyperbolas that open. They open sideways, these open up and down. So hyperbola with transverse axis along the y-axis. So if you keep the b squared under y squared, asymptotes are identical in both cases. In some texts, they change that. I don't like to change that. I think it's easier to understand it this way. Now, this is called a fundamental rectangle. Fundamental rectangle, when you look at this point A0 minus a0, 0, b0 minus b, and you create a rectangle such that this point has coordinates a comma b, a minus b, minus ab, minus a minus b, and you draw this rectangle. The reason they call it a fundamental rectangle, because the two asymptotes are the two lines that you can see. It's the diagonal of those of the uh, rectangle. So one way to come up with these two lines is to make up this fundamental rectangle. Connect these two vertices, create a diagonal, and continue indefinitely. And by the way, it's a dashed line because it's not part of the graph. It's the asymptote that helps you see the graph. So in short, x squared over a squared minus y squared over b squared equals 1, or y squared over b squared minus x squared over a squared equals 1. In both cases, a squared plus b squared equals c squared, because c, the focus, is here somewhere, and the distance from here to the center, in this case, is somewhere here, the distance to the center, and c is larger than a and b always in the case of a hyperbola, which is not the case in the case of an ellipse. So, terminology. Two hyperbolas that have the same set of asymptotes are called conjugate. So these two have identical asymptotes. And notice, this is A, this is B. And if you draw a fundamental rectangle, for both of them is the same. This is, it's not as perfect as, of course, this one, but that gives you an idea. All right. So here's the formulas that have been discussed. Here's the graph. Here's the two vertices. Here's the two foci, focus 1, focus 2. Okay. And here's a point with coordinates x comma y. And here's the distance from P to F prime. And here's the distance from P to F. Their difference is constant. Fundamental rectangle. A0 minus A0, 0, B0 minus B, y equals B over A times X, y equals minus B over A times X. So those are the equations of the asymptotes. If you solve for y here, that means you say x squared over a squared minus 1 equals y squared over b squared. In other words, if you move this one to the other side, this one to this side. And now if you multiply by b squared, okay, you get b squared times x squared minus a squared over a squared equals y squared. you get b squared over a squared times x squared minus a squared equals y squared. Up to here. I hope you're with me. So y is, take a root of both sides plus minus. So y is plus minus b over a square root of x squared minus a squared. If absolute value of x is large, the difference of x squared minus a squared approaches x squared. I want to make sure we understand the concept of asymptote and how we arrive at this. So I want to prove the asymptote. So let me erase my work. What happens if x gets larger and larger and larger? That's the idea behind the asymptotes as x approaches infinity. No matter how big this number is, a squared compared to x squared is nothing. For all practical purposes, it goes away. So you have plus minus b over a times the square root of x squared comes out as x, and it gives rise to the equation of asymptote. This is the definition. When absolute value of x gets larger, that means x approaches either infinity or negative infinity, which means ultimately the graph runs along the line. Okay, that's the idea behind the asymptote. The distance that m minus n that was discussed, this distance minus this distance is plus minus 3. The reason we say plus minus 2a, if by any chance you choose the point here and you notice that if I pick a point here, this is smaller than this one, we say plus minus 2a. Why is that? Let's look at the case. If this is the case always, that means any point that you pick must have the same property. So what about V if we pick this point? This point has the same properties. It's because it's on the graph. So V F prime minus V F must be the same. Now by symmetry, this distance is the same as this distance. So VF prime minus V prime F prime. I can change the VF. Let me show you on the graph. Let me clean up and let me show you the part that I'm referring to. This portion, everybody, this distance is the same as this distance by symmetry. So we can replace this distance, which is VF, by this distance, which is V prime F prime. That's what we did. So V F prime minus V prime F prime is this distance. Now this is V prime, which is 2a. So believe it or not, that's the proof. And by definition, a squared plus b squared equals c squared. C is this distance, by the way. So in this case, this is the A distance, this is the B distance. So look at the A, it's easier to see the A, the B, and if you connect these two, so this is B, this is A, and this has the same distance as C. So the focus is where a squared plus b squared becomes c squared. That's how you find the location. Now let's look at the proof for the equation of a hyperbola. Let's look at that one. The distance between P and F. So I'm going to go over that, and I'm going to try to go over it as fast as possible. You're not responsible for the proof. If you can follow it, it makes it, that much easier. The distance from P, this point, to F, and then the distance from P to F prime. So from here to here, we are going to follow the distance formula, x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared under the radical. So x minus c quantity squared plus y minus 0 quantity squared under the radical. What about this distance? Pf prime, same concept, x minus c quantity squared plus y minus 0 quantity squared under the radical, and x minus c becomes x plus c. And we know the difference between the two, we said it's 2a. So the difference between these two is 2a. So we're going to concentrate on this part. And what we are going to do, this negative, we're going to move it to the other side, make it positive. And because we don't want to work with it the way it is, we are going to raise both sides to the power of 2. That means raise this to the power of 2, get rid of the square root, raise this to the power of 2. And that means this becomes 4a squared plus 2 times this one times this one, which makes it 4a times this one, plus take this one out. I'm raising both sides to the power of 2. You should have no problem doing this math. X plus c squared is x squared plus 2cx plus c squared. This is the same, this is the same, and this is the same. This one is x squared minus 2cx plus c squared. This is the same. X squared from both sides. Don't move them, just get rid of it. C squared plus y squared are identical from both sides. Just get rid of it. This one we are going to keep. This we will move, becomes negative. And this guy with this guy, they combine into 4cx. I hope everybody's clear on that. We notice there's number 4 involved. We can factor the 4 out or just simply divide both sides by number 4. It makes it easier. And now we have to square it again. So this is c squared x squared. This is minus 2ca squared x. This is plus a to the power of 4. This one is a squared, and this thing comes out. So this doesn't change. This one changes to x squared minus 2cx plus c squared. I'm going to multiply the a squared by it. So everything gets multiplied by a squared on the right side. The left side is unchanged. These two are identical. Just drop it. Just move it to the right, becomes negative. Just move it to the left, becomes negative. The reason we do that, on the left side, we can factor out the a squared. On the right side, these two pieces, we can factor out the x squared. And now we are almost ready. We want to get this one. So we divide both sides, everybody. Take a look. We are going to divide both sides by this. The left side, divide both sides by left side. So the left side becomes 1. If you're dividing this one by this one, a squared minus c squared goes away, becomes x squared over a squared. And this one, a squared goes away, you get y squared over a squared minus c squared. We are almost there. We know a squared plus b squared equals c squared. Therefore, a squared minus c squared is minus b squared. And you can bring this negative out. And believe it or not, that's the proof. Again, you're not responsible for the proof. If you can follow it, you are in good shape, everybody. Okay, let's get started. Graph hyperbolas. Determine the equation of the asymptote of the hyperbola and graph it. To graph hyperbolas, we need a couple of things. First of all, you compare it to the format that is the standard form. In this case, x squared over a squared minus y squared over b squared equals 1, and clearly looks like that. So a squared is 9, b squared is 16, and therefore it makes a 3 and b 4. This is centered at 0, 0. So 0, 0. Now, because x squared over 9, because this has a positive sign. See, this has a positive sign, so we have x-intercepts for the vertices. This one, y squared, has a positive sign. We have y-intercept, okay, as the vertices. So that being the case, the vertices are located at a, 3, 0, and minus a, negative 3, 0. And those are the two pairs. The asymptotes y equals plus minus b over a times x, therefore is plus minus b over a, 4/3 x. There are two asymptotes, and you can graph this by picking up a couple of pairs, class. For example, both of them will go through 0, 0, so that's easy. And then just for the sake of argument for this one, if you pick 3, y becomes 4. If you pick 3, y becomes negative 4. I hope you see that. So both of them go through 0, 0. Okay, just as an example, both of them will have the pair 0, 0. This one, if I pick 3 for x, then y becomes 4. This one, if I pick 3, y becomes negative 4. So it's easy to graph it. Also, the fundamental rectangle is easy as follows. Always there are this, and I hope you see that this represents 4 pairs, plus minus a, plus minus b. So for example, a, b, okay, would be 3, 4. 3, 4, a, b. 3, 1, 2, 3, 4. It's here. And then another point, and then another point, and another point, and then draw the diagonals, and there you have it. So there are 4 pairs, and those 4 pairs give us the fundamental rectangle. And if you draw the two diagonals, that would be the asymptotes. Also, these points 0b and 0 minus b are also there as sort of a reference point. So these are the two asymptotes. This one, everybody, is y equals 4 thirds x. This one is, let's just write next to it. So this one, y equals 4 thirds x. Okay. So the purpose of the fundamental rectangle is to help us see the graph. And so these are the vertices, so the graph opens sideways. Okay. So that's the graph. We want to find the foci. It would be helpful, and the fact that a squared plus b squared equals c squared is going to help. So c squared is 25, and c becomes 5, everybody. So we have plus minus 5, 0. So one of them is here, one of them is here, and we are done. These are all the graph. Oh, this is all the graph we need. And that's it. Very straightforward, everybody. So in short, find the center, A, B, vertices, it opens up or down, and fundamental rectangle helps find the asymptotes. And there you have it. By the way, just for the sake of argument, and I'm going to explain it quickly here. If the question was the following, let me see what color I want to use here so it becomes clear. Let's say the question was, let's find y squared over 16 minus x squared over 9 equals 1. So pay attention to this. Let's say this was the question. Then, aside from the graph, everything else is the same, meaning the asymptotes are the same, the fundamental rectangle is the same, but the graph for this will look like this. Take a look, everybody. This would be the graph, okay? Meaning it really helps to see the two, compare and contrast. What about the foci? In this case, the foci would be at, again, the same thing, a squared plus b squared equals c squared.
Professor, are you okay?
All right, something happened, class. So we're going to quickly go over the same question that we covered. So we want to determine the equation of the asymptotes of this hyperbola. And to do so, first and foremost, notice that when we compare it to this one, a squared and b squared are 9 and 16. Therefore, a is 3 and b is 4. It's centered at 0, 0. Because the coefficient of x squared is positive, we have x-intercept as the vertices, plus minus 3, 0. That means a and negative a. The equation of asymptote plus minus b over 8 times x, that means plus minus 4/3 x. If we were to graph them fairly fast, they both go through 0, 0. And if in this case, for the sake of argument, if you pick x to be 3, cancels out the 3, y becomes 4. In this case, if you pick 3, you get minus 4. But in any event, it's easier to go with the fundamental rectangle, in which case it's plus minus a plus minus b. So for example, a, b would be 3 units to the right, 4 units up. And then the same thing here, same thing here, same thing here. And if you draw that, the diagonals are our asymptotes. And it's really a good idea to have this b equals 4, so 0, 4, and 0, negative 4 as a reference point. These are the two asymptotes. So as far as the equation is concerned, of course, this is y equals 4/3 x. This is y equals minus 4/3 x. And this is the graph. Now, finding the foci, a squared plus b squared equals c squared. C squared becomes a 25. Therefore, c is equal to 5. And the foci are along the vertices, also the transverse axis. And so it becomes 5, 0, and negative 5, 0. Those are the two pairs. Also, I want to quickly mention what I mentioned a minute ago. If we had y squared over 16 minus x squared over 9 equals 1. And by the way, I like to keep the a squared under x squared and b squared under y squared. If you do so, the asymptotes don't change. In that case, you have the same information except the graph is changing in the following manner. The graph would be this, everybody. And the vertices would be at 0, 5, 0, negative 5. That would be the difference. Determine the equation of asymptote of the hyperbolas. Again, we see it in the format x squared over a squared minus y squared over b squared. Therefore, a squared 25, b squared is 49. That makes a 5 and b 7. Centered at 0, 0. Because the coefficient of x squared is positive, then we have the vertices at 5, 0, and negative 5, 0. The equation of asymptote plus minus b over 8 times x, therefore plus minus 7 over 5 x. And as I mentioned, they both go through 0, 0, obviously. If you choose x to be 5, you get 5 and 7. In this case, you get 5 and minus 7. The fundamental rectangle, the purpose of that is to help us graph the asymptotes. Plus minus a, plus minus b for example, simply 5, 7. So 5 here, 7 up. Okay, 1, 2, 3, 4, 5, 6, 7 gives us this point and the other 3 points. Plot them, graph them. Let's also graph this 0b and 0 minus b and the two diagonals, and everything is in dashed line format because asymptotes are not part of the graph. And so the graph looks like that, and we are done. And those are the endpoints that we connect for the diagonals that were mentioned. Now, again, let's find the foci. A squared plus b squared equals c squared, which makes c squared AD as 64, and therefore c is 8. And the foci is at 8, 0 and negative 8, 0. And those are the points. Very straightforward, everybody. Now, graph the hyperbola y squared over 16 minus x squared over 1 equals 1. By the way, even if 1 is not there, then you should put it because you want to recognize that. And it's in the form that you see here. So in this case, a squared is 1, b squared is 16, so that makes a 1 and b 4. And because so the center is still at 0, 0. But what about the vertices? Because the coefficient of y squared is positive 1 over 16, then we have the vertices along the y-axis. So 0b and 0 minus b, 0, 4, and 0, negative 4. Still, we use the same formula, y equals plus minus b over a times x for the vertices. And that makes it plus minus a 4 divided by 1. That means 4x and minus 4x. Plus b is 4, a is 1, 4 over 1 is 4. And again, they go through the origin. And in this case, if you choose x to be 1, for example, you get 4 here, you get minus 4 here. And it's not a bad idea to come up with the fundamental rectangle. And that means, for example, 1, 4. So 1, 4, and the other 3 points. So minus 1, minus 4, minus 1, 4, 1, negative 4, 1, 4, and that's the rectangle. And the two asymptotes go through the diagonals, okay? So obviously this is y equals 4x. Let me write next to it. So this is y equals 4x. And this one is y equals minus 4x. And again, it's a good idea to find the foci. And so again, those 2 points, just, just like as we did with the other graphs, just for reference points. And a squared plus b squared equals c squared. Okay, so that's the graph, everybody. So this one, and that's the graph with giving us, the vertices. And a squared plus b squared equals c squared makes c squared equals 17, or c is square root of 17. Okay, by c we mean the distance here, okay? Otherwise plus minus. So the foci are along the y-axis, everybody. Along the y-axis at 0 square root of 17 and 0 negative square root of 17. And square root of 17 close to 4. So negative 4.1, 4.1, these are the, and we go with the decimal for the sake of graph. It's very close to the vertices, but it's not, of course, at vertices. The reason they're close because A was extremely small. So opens up and down. Okay, opens up and down. Now, find an equation of hyperbola. We want to find an equation of the hyperbola having one vertex at 0, 2, which means, and foci at 0, negative 3, and 0, 3. Right here, because of the way it's set up, this one tells us the center is at 0, 0. the C is 3 and the B is 2. So B is 2, C is 3, center at 0, 0. Those two pieces of information give us the three pieces of information here. Center, C, B. Vertices, if one is at 0, 2, the other one must be at 0, minus 2. Now, let's find a squared plus b squared equals c squared. And a is missing. 4, 9. So a squared must be 5. And because the vertices and the foci are along the y-axis, we are using this formula, everybody. Y squared over b squared minus x squared over a squared equals 1. And we get y squared over 4 minus x squared over 5 because a squared is given. Equals 1. So that's the equation. Okay. Looking like that, the fundamental rectangles. Okay, plus minus b. A happened to be square root of 5, about 2.24 for the sake of graph, okay? And here's the fundamental rectangle. Here's the asymptotes. And the equation plus minus b over a times x, which makes it 2 over, remember, a squared is 5. So a is the square root of 5. So those are the two equations. Very straightforward, everybody. Analyze the equation. When we have x squared and y squared on the same side, by the way, that is one of those conic sections would be a circle or an ellipse or a hyperbola. If the two are identical, the two coefficients is a circle. If the two are not, but they have the same sign, is an ellipse. If they have different sign, is a hyperbola. The methodology is to divide both sides such that this becomes 1. So this divide by 36. You want it to look like this one or this one. So if I divide this one by 36, I get 1. This one, I get x squared over 4. This one, I get minus y squared over 9. So now a squared is 4, b squared is 9. So clearly a is 2, b is 3. So practically we are done because the center is at 0, 0. The vertices, because the coefficient of x squared is positive, are at 2, 0 and negative 2, 0, plus minus 2, 0. Y equals plus minus b over a times x is the equation of the asymptotes plus minus 3 halves x. The fundamental rectangles, we are going to write a and b. So 2, 3, negative 2, 3, and 2, negative 3, negative 2, negative 3. There are 4 pairs. We can find the value of a squared plus b squared equals c squared. So c squared is 13. And the foci are, because the vertices are along the x-axis, so are the foci plus minus square root of 13, 0. And this one, we put it into a calculator, roughly it becomes 3.6, roughly. So negative 3.60, 3.60, and this is the complete graph. Notice we have those two for reference points. These are the vertices. These are F1 and F2. These are the two asymptotes, uh, plus minus 3 halves x. As far as a graphing calculator is concerned, you have to solve for y, which means we are going to move the negative for x squared becomes positive for x squared. So if you take a root on both sides, 5y becomes plus minus square root of 9 plus 4x squared under the radical. Divide both sides by 5. Plus, you could also divide, I mean, another way is to divide this one. If you divide this one by 25, you can get here. Either way is fine. So now, again, the way the graphing calculator works, you have to put y1 is positive, 1/5 squared of 9 plus 4x squared, and y2 is negative, and then it gives you both pieces. So y1 is the positive part, and y2 is the negative part. So analyzing hyperbolas with center at h and k. So if the center moves from 0, 0 to hk, the formula for this one is x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. For this one, this takes a positive value. So y minus k quantity squared over b squared minus x minus h quantity squared over a squared equals 1. And the asymptotes move by h and k. So that means you use the same formula next to y. For y, you use y minus k. For x, you use x minus h. That's how you find the asymptotes. Okay? So the methodology is to find the center and then move A units to the right and left, or B units up and down for the vertices. That's the concept. All right. Graphing hyperbola, a hyperbola that's been translated from the origin, y plus 2 quantity squared over 9 minus x plus 3 quantity squared over 4 equals 1. So this is the same as, if you ignore that, it's the same as y squared over 9 minus x squared over 4, but now it's been shifted such that it's the center from 0, 0 has moved to -3, -2. So this hyperbola has the same graph as y squared over 9, ignore that, minus x squared over 4, ignore that, except that it is centered at -3, -2. The center of 0, 0 has been moved in essence, which means it has been moved 3 units to the left, 2 units down. So you could graph this one and shift it 3 to the left, 2 down, and that's your graph. That's one way to look at it. Now the center is at -3, -2 with a squared being 4, b squared being 9, okay? And so a is 2, b is 3. Here's the center, -3, -2. So the vertices, because this one has a positive coefficient, the vertices are up and down by b or 3 units. So take this up and down. That means -2, add and subtract 3, plus minus 2. That's the meaning of it. So the x coordinate doesn't change. The y coordinate becomes -2, -3, which is -5, and -2 plus 3, which is a +1. So it's pretty straightforward. So those are the two pairs. Now, y equals plus minus b over a times x. Now we're going to go with y minus k. That means y plus 2. Okay, so let's just write the equation. So y minus k, whatever that you have here, just this is your y minus k. So y plus 2 plus minus b over a 3 over 2 x minus h, x plus 3. So that's the equation. If you work it out, and we are going to move this to this side, subtract. So if you work this out, and I'm going to leave it for you to do that, becomes 3 halves x plus 9 halves minus 2. Just write that and I'm going to erase it. So there are two things that happen here. One of them is 3 halves x plus 9 halves minus 2. The second one would be minus 3 halves x minus 9 halves minus 2. And that gives rise to these two equations, okay? And these two equations, you can draw those lines easily. And when you draw those lines, they must go through this point. You obviously see the y-intercept at 0, 5 halves. This one at 0, negative 3 halves. And even if you just draw the y-intercept for each one, since you have this point, you can graph it. As far as the fundamental rectangle is concerned, let me erase my word. The fundamental rectangle has vertices at a equals 2 units to the right and left of the vertices. So we have the following. Here's the vertices, right? And because it opens up and down, so you go a units, which is 2 units to the right and left. 2 units to the right and left. Those are the 4. Those are the fastest and easiest way. So that is the fundamental rectangle, and that is the graph. I highly recommend you make sure that these two equations make perfect sense to you. Okay, last question. Write the equation of hyperbola in standard form. Identify the coordinates of the center, the vertices, foci, and everything else there, and graph it. So here's what's given. And remember, as we did with circles, with ellipses, we want to put them in standard form, which means we are going to put the 9x squared and minus 18x together, these two together, and we are going to move the 43 to the other side if it wasn't the case. It is the case already, okay? But if it's not, that's the methodology, okay? Now, we are going to take the 9 out. We get 9 times x squared minus 2x. And this one minus 4 times y squared plus 4y. Now we're going to do the perfect square. So completing the square, what is missing here? So over here, where do I want to put this? So over here, class, b is negative 2. b over 2 is negative 1. Square that, you get positive 1. Okay. Over here, Let's see this one. Use a different color. Over here, b is a 4 divided by 2 is 2 squared, we get 4. So what does it mean? I need to add 1 here. That means I'm adding 9 times 1. So I'm going to add 9 here. I need to add 4 here. That means I'm adding negative 4 times 4. Negative 4 times 4. Okay. So plus 9 times 1, plus 9 times 1, minus 4 times 4. This becomes x minus 1 squared. This becomes y plus 2 squared, and they add up to 36. Divide both sides by 36 to make the right side 1. And we get x minus 1 squared over 4 minus y plus 2 quantity squared over 9 equals 1. We are in business. So that's the equation in standard form. We want to find everything else and graph it. So first and foremost, a squared is 4, b squared is 9, which makes a2, b3. And because the coefficient of x, this one is positive, then it's along or parallel to the x-axis in essence. So the vertices, first and foremost, are located at positive 1, negative 2. Please understand how this negative means positive 1 here. So that's the center. The vertices use the A, so we are going to add and subtract 2 from the x coordinate. So from the center, we go A units to the right, A units to the left. When we go units to the right, this becomes 3, to the left becomes negative 1. Asymptotes. Y minus k, that means just use this one, y plus 2. Y plus 2 is plus minus b over a, 3 over 2, x minus h, x minus 1 squared. I just moved that in one shot, class. Okay, so this was y plus 2. I put the 2 over the other side. I highly recommend you simplify this so you'll be able to see those asymptotes. The fundamental rectangle has vertices at b equals 3 units above and below the vertices. Because we have the vertices in this manner, we go up and down by b units, and we get the fundamental rectangle. So perhaps finding the fundamental rectangle first and drawing the diagonals is easier to find the asymptotes, but that's the equation of the asymptote. The fundamental rectangle help us graph. That's the graph of the hyperbola. To find the foci, a squared plus b squared equals c squared, which is number 13. So from the center, we go by square root of 13 to the right and to the left, meaning 1 plus minus square root of 13 and minus 2. Now, roughly, putting it into a calculator, we get negative 2.6 minus 2 and positive 4.6 minus 2. Those are the precise location of the foci.